flipped over to the back of the incomplete dominance notes. And just like with codominance, we're going to do problem number 1 together. And then I'll give you time to complete 2 and 3, and then unpause the video and come back for the answers. So question number 1 says, in the 4 o'clock, which is the name for a flower like a petunia, the allele for the red flower is incompletely dominant over the allele for white flower. On the front, we use red and white flowers for a reason. This is a true instance of a trait that is incompletely dominant. So when a red 4 o'clock flower is crossed with a white 4 o'clock flower, an intermediate pink flower is the result. This intermediate just means that the pink is a blend of the red and the white. They want us to cross a homozygous red and a homozygous white, and then to cross 2 pink floroclocks. So that I don't skip any steps, I'm going to repeat assigning my letters. So R stands for red, W stands for white, RR, homozygous red, is a red flower, WW, homozygous white, is a white flower, and RW, which is the heterozygous genotype, is going to be a pink flower. So in cross number 1, they want me to cross a red and a white. So my parents are RR and WW. All of those offspring are going to be pink flowered. And in cross 2, they want me to cross 2 pink 4 o'clocks. So my parents for cross 2 are both RW, pink flowered. And when I cross them, I get 25% red flowers, 50% pink flowers, and 25% white flowers. So the last step of the problem is to interpret the Punnett square to answer the question. I have 3 questions here. The possible phenotypes of cross 1 are all pink, so I'm going to say that they are 100% pink. Again, phenotype is the physical characteristic. The possible phenotypes of cross 2 would be 25% red, 50% pink, and 25% white. I combined this third question up here. It just wanted me to, in addition to giving the possible phenotypes, give the percent chance that each one gives up or ends up in an offspring. Pause the video now to complete problem number 2 and problem number 3, and then come back for the answers. All right, number 2 is talking about guinea pigs and the color of their coat or their fur. Yellow coat is determined by homozygous YY, so they told us that yellow is Y. White coat is determined by homozygous WW, so W stands for white. And cream is the third phenotype, which is created by heterozygous YW, or a blend of yellow and white. Before I look at any of the rest of the question, I'm going to use that information to do step number 1. Y is for yellow coat, and W is for white. YY is a yellow-coated guinea pig. WW is a white-coated guinea pig. And YW is a cream-coated guinea pig. The question then wants me to determine the expected genotypes and phenotypes and their percent chance of occurring for the generations that would result, and then they gave me 2 sets of parents. So basically complete the Punnett square and then give the percent chances for the genotypes and phenotypes of the cross. I've done step number 1. That's going to apply to both A and B. So step number 2 is to write the parent cross. In question A, my parents are both cream, which I know is YW. So I'm going to cross 2 cream guinea pigs. And then I'm going to give the percent genotypes and phenotypes. Based on this cross, there is a 25% chance of the genotype YY, 1 out of 4 boxes. There is a 50% chance of the genotype YW. And there is a 25% chance of the genotype WW. And each of those genotypes pertains to a different phenotype. So there is a 25% chance that my guinea pig will be yellow, a 50% chance that my guinea pig will be cream, and a 25% chance that my guinea pig will be white. In part B, I'm again using the same letters and genotypes, but this time I'm crossing a yellow guinea pig and a cream guinea pig. So my parent cross is a yellow, or a YY, cross with a cream, which is YW. So when I complete the cross, there is a 50% chance of a YY guinea pig, which will be yellow, and a 50% chance of a YW guinea pig, which will be cream. Number 3 is crossing a blue Tweetsie bird and a white Tweetsie bird. So blue is one of my phenotypes and white is one of my phenotypes. And the question tells me that the cross between a blue Tweetsie bird and a white Tweetsie bird produces offspring that are silver. Because the bird color is incompletely dominant, I can go ahead and assign my letters. B in this instance will stand for blue, and W will stand for white. I know that silver is the 3rd phenotype produced by the cross of these two. So BB is going to be a blue Tweetsie bird. WW is going to be a white Tweetsie bird. And the heterozygous combination, BW, is going to be the silver Tweetsie bird. All right. A wants to know the genotypes of the parent Tweetsie birds. So essentially it wants me to write the cross. It tells me that the parents are blue and white. So I know that their genotypes are BB and WW. BB is the only way to be blue and WW is the only way to be white. The genotype of the silver offspring is going to be BW, since BW is the only way to be silver. And part C wants to know what would be the possible phenotypes and their percent chance of occurring in a cross between two silver Tweetsie birds. My step number 1 will still apply since I'm still dealing with blue, white, and silver. So my parent cross is going to be a BW crossed with a BW since they are both silver. And when I cross them, the question wants to know the possible phenotypes and their percent chance. So based on my Punnett, there is a 25% chance of a blue Tweetsie bird, a 50% chance of a silver Tweetsie bird, and a 25% chance of a white Tweetsie bird.